Welcome everyone to a new chapter. Today we're going to be starting the chapter about the unit circle. So we did right triangle trig for a while. Now we're going to do unit circle trig. Okay? Standard position. So as you can see back here, let me go back. This is what the unit circle looks like. It's just a circle with radius 1. There's going to be angles around this thing. The first thing we'll talk about is standard position. We measure angles on the unit circle by starting on the right side and moving counterclockwise. So this is the initial side, this is the terminal side, and this is the angle inside. The symbol we use looks like this, and we say it's pronounced theta. And so since there's no symbol like this on the keyboard, I usually just write the word theta if I need to. This is the unit circle. We'll talk a lot more in class about how it's developed. You'll have plenty of time to practice it. 2 classes after I give it to you, you'll have a memory quiz on it. But here's the key things. There are a 30 degree, a 45 degree, and a 60 degree. And then these are the same angles on this side, and these are the same angles on this side, and these are the same angles on this side. So this would be a 30 degree angle right here. This would be a 45 degree, this would be a 60, this would be a 90. This would be 120. And notice that not only do you have to know all the angles, but you have to know the points that go along with them. But if you notice this, a lot of them have the same thing. Like those two are just the same things but switched. And these two are the same things as these two, but with a negative x value. Okay? So we'll talk about the patterns a lot in class, but for the one thing that you have to do, you have to memorize the angle in degrees. You have to know the point, and you have to know this thing. This is another way to measure the angle. It's called radians. Those extra angle measurements that use the pi symbol are called radians. Basically, 180 degrees is pi, and 360 degrees is 2 pi. So that's another way to measure angles. That's why when we use our calculator, we want to make sure that we are in radian mode for this chapter, not degree mode anymore. Okay? We use radians exclusively in calculus and higher level math. So we have to learn about how to use them now so we don't have to worry about them later. To make life really easy, 180 degrees is pi. That's the relationship between the radians and the degrees. If I have something in degrees, I'm going to multiply by pi over 180 to make it in radians. And it makes sense because the 180 degrees on bottom, degrees will cancel, and now you're in radians. If it's the other way, if you're in radians and you want to convert to degrees, you multiply by 180 degrees over pi. So let's try that. I have 35 degrees. I want to turn it into radians. Well, I know there's 180 degrees in 1 pi radian. So I'm even going to let the calculator simplify it for me. 35 divided by 180. Math, enter. So I've got 7 over 36 pi. And just to let you know, we will usually write radians as 7 pi over 36. They're the same thing. Okay? So to go from degrees to radians, I multiply by pi over 180. If I go backwards, I'm going to multiply by 180 over pi. And notice here, this pi and this pi will cancel out. So I just have 9/5 times 180. So 9/5 times 180 is 324 degrees. So degrees to radians, radians to degrees. You'll have to know how to do both of those. Coterminal angles. Just like a clock, think about it on a clock. 2 o'clock a.m. and 2 o'clock p.m. look the same, but they're not the same time. There's also things that look the same on the unit circle, but they're not the same angle. For example, 30 degrees on the unit circle, which looks like this, is the same thing as 390 degrees. Why? Because if you were to wrap around all the way, that's 360 degrees, and another one makes 390 degrees. Another 30 degrees would make 390. They're in the same spot. You don't see it went around 390 degrees. You only see where it ended up, which was this. And negative 330. If I went backwards 330 degrees, I would still end up at the same spot. Those are all coterminal. Okay? So how could I find a coterminal? Well, here I added 360 from the angle that I knew. Here I subtracted 360 from the angle that I knew. Why did I use 360? Because I'm talking about degrees. Let's talk about two coterminal angles with 3 pi over 4. Now I'm in radian mode. I can't use 360. I'm going to do the same thing. I'm going to add 1 rotation and subtract 1 rotation. But I have to add 2 pi this time, because 1 rotation is 2 pi. Okay? Instead of using 2 pi, I'm going to use 8 pi over 4, which is the same thing as 2 pi. Now they're common denominators, so I can go over 4. 8 pi plus 3 pi is 11 pi over 4. So that's one angle that's coterminal. It's in the same spot as 3 pi over 4, which, just to show you, on the unit circle was right here. So it's way over here. But it's been rotated all the way around. Instead of adding 2 pi, I could also subtract 2 pi. Again, I'm going to use 8 pi over 4 to represent 2 pi. And that's negative 5 pi over 4. Now notice, these angles aren't in standard position. They're not between 0 and 360. These two angles are not between 0 and 360. These two angles are between 0 and 2 pi. But they are coterminal. They do exist. They're just not in standard form. Standard position. Since we have an infinite number of times it can wrap around, how will we name them? We're only going to name them between 0 and 360 or 0 and 2 pi. In other words, somewhere between the beginning and 1 rotation. We'll never name them after that 1 rotation. Okay? So all angles in degrees have to be between 0 and 360, and then radians between 0 and 2 pi. So find the coterminal angle in standard form. 791 degrees. That's not between 0 and 360. Is it too big or too small? Well, it's too big. So let's subtract 1 rotation. But 1 rotation in degrees is 360 degrees. So if you do that, you get 431 degrees. But wait a minute, that's still not in standard position. It's still bigger than 360. So we're going to have to subtract 360 again. You do 1, you have 42, 61 degrees. So think about this. This angle is the same thing as that angle if I wrapped this angle around 2 times. 9 pi over 2. Well, 9 pi over 2 is the same thing as 4.5 pi. That's too big. It can't be bigger than 2 pi. So I'm going to subtract 2 pi. Well, instead of subtracting 2 pi, I'm going to subtract 4 pi over 2. Why am I using 4 pi over 2? Common denominator. Now you have 5 pi over 2. 5 pi over 2 is 2.5 pi. That's still too big. It's not between 0 and 2 pi. So I'm going to subtract 4 pi over 2 again. Why am I doing 4 pi over 2 instead of 2 pi? It's the same thing, but now I have a common denominator. When you subtract, you get 1 pi over 2. And 1 pi over 2, that's 0.5 pi, and 0.5 pi is definitely between 0 and 2 pi. So, I subtracted 360, I subtracted 2 pi until I got something that was between the points I wanted. What if I would have started with negative numbers? Well, then I would have added until I got to what I wanted. Arc length. So not only are we going to talk about how far it opens up, but we're going to talk about how big the arc was it created. The good news is there's a formula. The arc length is equal to the radius. If it's not a unit circle, this is going to be something besides 1. And then the angle in radians. So L equals r theta. A point on a circle with radius 5, so r equals 5, travels 11 pi over 4. 11 pi over 4 is an angle in radians. Good, so I can say 11 pi over 4 is theta. So my function is L equals r theta. That's my formula. I don't know how long it is, but I know that the radius is 5. This is 11 pi over 4. And I'm just going to multiply straight across. 5 times 11 is 55 pi over 4. That's the exact answer. That's how far it traveled. Now, I don't know what that is as a decimal, and I don't care. That's the exact answer. A tire with 13-inch radius, so R equals 13. Travels for 8 feet. So there's two things here. I know the length is 8 feet, but I don't want it in 8 feet. I'm measuring this in inches, so we should measure that in inches. And since there are 12 inches in a foot times 8 feet, it's 96 inches. What's the angle? So I don't know what the theta is. So I set up a function, my formula, L equals R theta. How long is the arc? It was 96 inches. What's the radius? It was 13 inches. Theta, 96 over 13, radians. This doesn't have a pi in it, but that's okay. It traveled that many radians. So the big things to take away from this lecture are memorize the unit circle. The sooner you learn it, the better you'll be. Even though you don't know what it's used for yet, by knowing the unit circle, your problems will get easier. Converting between degrees and radians, and then standard form. It's got to be between 0 and 360 or 0 and 2 pi.